y equals negative 1/3 x squared plus 2x plus 1. What we're going to do is graph it, find the vertex, axis of symmetry, x and y intercepts. So we'll start off the same. We have x, y. We'll make a table, negative 1, 0, 1. Plug in negative 1. Negative 1 squared is 1 times negative 1/3 is negative 1/3. Minus 2 plus 1, so negative 1 minus 1/3 is negative 1 2/3. 0, that one's easy, just plug in. 0, we get 1. Plug in 1, we get negative 1/3 again, plus 2 plus 1, and this time we get 3 minus 1/3, which would be 2 2/3. Let's plot the points. It's the same as the paper I've given before, so it's second to the end. 0, 1, negative 1, negative 1 2/3. That means we're going to break this up into 3 equal intervals. So that would be about there. And then we have 1 and 2 2/3. So again, break it up into 3 equal interval, 2 marks, and we'll have a point there. How close are these? These are about 1 2/3, not about, exactly 1 2/3 apart. These are 2 2/3 apart. So it seems like we're getting closer to the right. So let's plug in some positive numbers. If I plug in 3, or 2 first, 2 squared would be 4 times negative 1/3, negative 4/3, plus 4 plus 1. So 5 minus 1 1/3, 5 minus 1 is 4, minus another third would be 3 2/3. 3 squared is 9 times negative 1/3 is negative 3, plus 6 plus 1, 7 minus 3 is 4. So 3 2/3, a lot of those 2/3. 3, 4. Seems like we're getting pretty close. Let's do 4. That'd be negative 16/3 plus 8 plus 1, so 9 minus 5 1/3. 9 minus 5 would be 4, minus another third would be 3 2/3. Notice here that these two values are the same. So what does that mean? That means our vertex is halfway in between there. So our vertex is going to be at the average of 2 and 4, which means it's this point there, 3, 4. So we can start putting, we know we already plotted this one or found it, so we plot it out. This is a symmetric point, so as I go 1 over, I'm going to go down to this one. I go 1 over here, and I go down to that same level, 2/3. Go over 1 again, we're going to go to the value of 1. Now let's connect the dots. And we want to try to make it look as symmetrical as we can. So this value here is x equals 3. That is our axis of symmetry. Our vertex is at 3, 4. Now take a look at that. Is that a coincidence? No. Our axis of symmetry must go through our vertex. The only point, again, on our graph that doesn't have a matching point is our vertex, and our axis of symmetry has to go through that. Let's see, we have our y-intercept. In this case, it's 0, 1. We have our x-intercepts, and we're going to need to find those. So our x-intercept is when y equals 0. Plug it into the equation. Now, when we're doing this, we can do this a couple ways. We can try to plug it into the quadratic formula right now, or we could get rid of this fraction and then do it. I think I'm going to get rid of the fraction just because more people will make mistakes with it. So if I multiply everything, we can multiply by 3 or negative 3. I'd prefer that a be positive. It's not a big deal either way. So I'm going to multiply by negative 3. So 0 times negative 3 would be 0. This one times negative 3, x squared minus 6x minus 3. So use the quadratic formula. Negative b, so the opposite of b. Now I started to write this down and I put in my square root. So negative of b, so 6 plus or minus the square root, there we go, of negative 6 squared minus 4 times a times c, all divided by 2 times a. Simplify that, we have 36 plus, because there's two positives there, plus 12 will give us 48 over 2. So this is 16 times 3. 6 plus or minus, and square root of 16 would be 4. Root 3 over 2. We can factor out a 2 from there, and then reduce that with this 2, so we'll get 3 plus or minus 2 times root 3. Square root of 3 is about 1.7. 2 times 1.7, about 3.4. 3 minus that will be about negative 0.4. And that's what we have. 3 plus 3.4, about 6.4. And that's pretty good. So there are x-intercepts. Is there anything else we need to know? Nope, that's it. Now we need to put it in vertex form. I'll show you a couple ways you can go about doing this. The first way is the longer way. Now, if I didn't make this table, which I don't have to make the table every time, I could use vertex form to help me get some of these values. What do we have here? We want to put it as a times some quantity of x minus h squared. Now we've done completing the square before, and this is just an extension of it. But we have to factor out an a, whereas before we would divide. So I'm going to factor out from this negative 1/3 x squared plus 2x plus 1. I'm going to factor out the negative 1/3. So negative 1/3 times x squared gives me negative 1/3 x squared. Negative 1/3 times what gives me 2? That would be times negative 6. Another way to do that is say 2 divided by negative 1/3, which is 2 times negative 3, gives us negative 6. And then there's an x, and then this would be negative 3. Oh, nope, I don't want that negative 3 there. I got a little carried away. So let's leave the 1 out there because I want to complete the square. What number would I plug in to complete the square? Negative 1/2 of 6 is negative 3. Negative 3 squared equals 9, so plus 9. Now, I didn't really add in 9. The number I really added in was negative 1/3 times 9. So I really added negative 3. So I can either think of it as subtract a negative 3, or I could just add in a 3. Whatever you like, you can do for that. So I can either subtract a negative 3 or add in 3 to counteract what I added into the problem, because negative 3 plus 3 will give me my 0. This gives negative 1/3 times x minus 3 quantity squared plus 4. That tells us our vertex is 3, 4. Our axis of symmetry is x equals 3. And I can plug in a couple points here to actually graph my equation. I would plug in numbers that would make it nice here. For example, 3, because then I would get 3 squared times 1/3. 6, because it would give me, again, negative 1/3 times 9. So make it a little bit easier. So let's still get 5 points in there. And that's it for that one. Oh, there's a little typo here. This should be 3. All right, sketch these graphs. Find all points of intersection. Y equals 9 minus x squared. What does that look like? That's a parabola, and it's going to open up or down. It will open down because the coefficient of x squared is negative. We can plot a few points. Let's go maybe 1, 2, 3, 4, 5, 6, 7, 8, 9. The x-intercepts of this thing will be at 3 and negative 3. I don't know how far I need to go down for right now. because if I plug in 0 for y, I get x squared equals 9. Take the square root. Remember your plus or minus. X equals plus or minus 3. This is only a sketch, so if I just start with my vertex here and I go down, that's okay. This is a line, y equals negative 2x plus 10. So I have a, and I go down 1, right 2, or down 2 and right 1. Down 2 and right 1. Now, this is hard to see on this problem, whether they intersect at all. I'm not sure. That's pretty bad, but that's okay for right in this second. Actually, I don't like that. How would we solve this algebraically? Well, I have 9 minus x squared and 2x plus y equals 10. I can use the same methods I've used before. The easiest one is probably a substitution. I can use my original equations, or I could use this one that's solved, whichever one you like. I think most would probably use substitution with this one. Let's move everything so the x squared is positive. So we have x squared minus 2x, and then plus 1. Factor that. So x minus 1 equals 0 and x equals 1. We're going to learn more about this one next chapter, but this is where it's called a multiplicity of 2, where we have x minus 1 occurring twice, so x equals 1 is a solution twice. If x equals 1, then y equals negative 2x plus 10, or 8. So this problem has one intersection point, and that intersection point is at 1, 8.